हेलो गाइस, चैनल पे नए हो तो सब्सक्राइब कर देना और लाइव स्ट्रीम देखना है तो मेरे चैनल पे जाके चेक कर सकते हो। ये रिकॉर्डेड देख रहे होंगे तो चलो पढ़ाई स्टार्ट करते हैं।
Good evening, friends. We are planning for our topics like this. Initially, we will be taking up the topic on TTT diagram. Once we complete the topic on TTT diagram, we will proceed to ask tempering, ask forming, and mark tempering. As soon as these topics are completed, then the next topic for our discussion will be subtending processes, and then the effects of alloying elements in steel. These are the topics that we are planning for coverage today. So join me, friends. We are initially going for discussion on the TTT diagram. TTT diagram. Let us try to remember that the full form of this particular diagram is TTT बोलने का मतलब है time, temperature and transformation diagram. Time, temperature, transformation diagram. दोस्तों हम लोग देख रहे थे in the electrolyte reaction that we have done, we have seen that austenite on cooling will transform into perlite. Austenite on cooling will transform into perlite बोल के electrolyte reaction देख लिया था. Now, iron carbide diagram does not tell us this reaction takes, this transformation takes how much amount of time and at what temperature. बोल के नहीं बोलता. ये वाला ट्रांसफॉर्मेशन आर्सेनाइड टू परलेट ट्रांसफॉर्मेशन कौन सा टेम्परेचर में कितना टाइम लेता बोलते नहीं बोलता आयरन कार्बाइड. इसी के वास्ते हमारे को ये दूसरा डायग्राम का कंस्ट्रक्शन करना पड़ा. सो दिस पर्टिकुलर डायग्राम TTT डायग्राम gives us the time required for arsenate transformation into perlite at a particular temperature. So let us see. We write one or two sentences here initially. That is according to electrolyte reaction. According to electrolyte reaction. According to electrolyte reaction, austenite on cooling transforms into alpha plus cementite. This alpha plus cementite is what is called as perlite, right? Now, so our interest is that we want to know this transformation will take how much amount of time and at what temperature. This transformation will take how much amount of time and at what temperature को find out करना हमारा लक्ष्य है. इसी के वास्ते हम TTT डायग्राम का कंस्ट्रक्शन कर रहा है. So TTT diagram gives you the time required for transformation of austenite at a particular temperature. The time required for transformation of austenite at a particular temperature. Because no, whenever we talk about certain transformations, the transformations we usually have essentially two components. These two components are called as nucleation component and growth component. Therefore, initially, we will try to discuss the fundamentals of TTT diagram. Right? The fundamentals of TTT diagram lie in a small graph that is now being taken. So let us see. Any transformation that you talk about can be included into this particular graph. Let us see. I try to draw a diagram wherein on y-axis I try to show temperature. On y-axis I try to show temperature, and on x-axis I try to show what is called as a rate. Let me say, for example, for this transformation to take place, the reference temperature is A1 temperature. A reference temperature is, let us say, A1 temperature. Right? Now, from A1 temperature, as the temperature is decreased, right, austenite will transform into perlite. Above A1 temperature, austenite is stable. Below A1 temperature, austenite is unstable. Because it becomes unstable, it undergoes a transformation into what is called as the perlite. Now, this transformation, for example, will have essentially two components. One is called as nucleation and the other is called as the growth. So I am trying to plot the rate on the x-axis. The rate means 1 by time. Rate means 1 by time. Alright. Now, temperature versus rate, if you plot, as I told, there are two components. These two components are nucleation rate and growth rate. Now you can identify that any transformation normally will be like this. With decrease in temperature, the nucleation rate keeps on increasing. This graph shows the variation of nucleation rate. Whereas I try to show you another graph. That is, with the decrease in temperature, growth rate keeps on decreasing like that. This graph indicates what is called as growth rate. Now, with the decrease in temperature, nucleation rate increases. With the decrease in temperature, growth rate decreases. Right? These are essentially two components of overall transformation rate. Observe, यहाँ से कौन सा जानकारी मिल सकता है हमारे? At lower temperatures, at smaller and smaller temperatures, lower temperatures, when temperature is decreased, nucleation rate increases. That means the number of nuclei of new phase that are formed will increase. That means at low temperatures, at several places in the material, new phase formation will take place. But at low temperatures, that new phase formed will be associated with small growth rate. At more number of places in the material, in the steel, you will find that austenite to paralytic transformation takes place. So nucleation rate is more. But high nucleation rate is associated with low growth rate. Therefore, though at many places the new phase paralytic is formed, it will not grow bigger because growth rate is less. Therefore, at low temperatures, fine-grained structures are going to be formed. As you go far away from A1, nucleation rate is more and growth rate is less. Large nucleation rate and small growth rate are associated with formation of fine-grained structures, fine paralytic structures. Similarly, as temperature is increased, let us see what's going to happen. As temperature is increased, nucleation rate decreases. When nucleation rate decreases at higher and higher temperatures, only at a few locations, new phase paralytic will form. But that small nucleation rate is associated with large growth rate at high temperatures. Therefore, though at a small place, at a fewer number of places, paralytic transformation starts, but that the paralytic formation the portion which is transformed into paralyte is associated with large growth rate. Therefore, it will grow bigger and bigger in size. So, at a few places, new phase paralyte is formed, but that new phase paralyte will be having more growth rate. Therefore, we understand at high temperatures, small nucleation rate and large growth rate are associated with formation of coarse paralyte. So, at high temperatures, coarse paralytic structures will be formed. At very small temperatures, fine-grained structures are going to be formed. This is what conclusion that we can make from here. Come on, friends, you can repeat this at also. At smaller temperatures, as the temperature is decreased, smaller growth rate and large nucleation rate are associated with formation of fine paralytic structures. At higher temperatures, small nucleation rate and large growth rate are associated with formation of coarse paralytic structures. One conclusion. Second conclusion is that if you want to plot the overall transformation rate is always the product of these two. The product of growth rate and nucleation rate gives you what is called as overall transformation rate. Therefore, if you would like to plot that, let us say for example, this is the product of these two. When plotted at every temperature, we give you the variation of overall transformation rate will be like that. That is how the overall transformation rate will vary. So this graph is showing overall transformation rate. Overall transformation rate. Overall transformation rate is obtained as product of growth rate and nucleation rate. All right. Next, as we look into this, from here I would like to translate these results into another graph. The other graph is called as temperature versus time diagram. Right? This is temperature versus time diagram. Now, what is the difference between these two diagrams? First diagram is having temperature on y-axis. Second diagram is also having temperature on y-axis. So no change in the y-axis. First diagram on the x-axis is having rate. The rate means 1 by time. And second diagram is having time on the x-axis. अब आइए कौन सा चेंज बनता है? Say for example, if this line is taken as A1 line as the reference line, come on. Overall transformation rate के बारे में मैं बोल रहा हूँ. Overall transformation rate के बारे में जब मैं बोल रहा हूँ, overall transformation rate initially increased and then decreased. But what is rate? Rate बोलते 1 by time. So 1 by time has initially increased and then decreased. तो फिर time का क्या होगा? If 1 by time is initially increased and then decreased, then what will happen to time? Reverse होगा. Initially decrease होगा, बाद में increase होगा. That means this graph should come like this. Right? This is the one which is belonging to overall transformation. That is the reason why in these two graphs I have drawn overall transformation graph with the same color. So you need to understand the graph I have shown here is indicating overall transformation time. This is overall transformation rate. On x-axis when there is rate, this curve will represent transformation rate. On x-axis when there is time, this curve will represent overall transformation time. Got the point? Now, what will happen to the overall transformation time? With decrease in temperature, overall transformation time will initially decrease and then increase. Now, जो आने वाला TT diagram है, whatever the TT diagram is going to come, that TT diagram is also having temperature on y-axis and time on x-axis. Right? That is the TT diagram is going to give you time for transformation at a particular temperature. So time, temperature, transformation diagram. यहाँ पर भी तीन है ना, ये वाला transformation का indicate कर रहा है, temperature and time. So आने वाला जो TTT diagram है, time, temperature, transformation diagram, exactly ऐसा ही दिखता है. Initially, TTT diagram will initially decrease in time and then it will increase in time. So आने वाला TTT diagram का जो shape रहता है बेटा, वो shape ऐसा बनेगा बोल के जो basis है, it is given by this particular graph. Now, how did you arrive at this graph? This graph is arrived at by considering overall transformation rate. But how did you know overall transformation rate? Overall transformation rate is obtained as the product of nucleation rate and growth rate. Therefore, these things will become foundation for upcoming TTT diagram. Now, keep this in your mind. The upcoming TTT diagram जो है बेटा ऐसा दिखता है. So, for the shape of TTT diagram, ऐसा आएगा बोल के एक basis तुम्हारा सामने लाया गया है. Now, once you understand this, we go to actual construction of TTT diagram. We go to actual construction of the TTT diagram, and then some physical interpretation. कौन सा conclusions ले सकते हैं बोल के वो वाला चीज देखेंगे अभी. So let us see how the TTT diagram is constructed. बोल के मैं आगे बढ़ रहा हूँ. Constructional aspects discuss करने के लिए आगे बढ़ रहा हूँ. Let us say data generation कैसा किया जाता है. देखिए, suppose this is the so-called A1 line. So-called A1 line. Initially data generation करने के लिए हम लोग क्या करेंगे? We try to take the austenitized ductile steel. When I say this type of sentences, you need to understand. Raw material is ductile steel area. Austenitized.
Hello Cartoon Club, how are you? क्या हाल है भाई? फाइन. सब यही बोलते हैं फाइन है, अंदर से कोई फाइन नहीं होता.
बोले तो ये बहुत ये मतलब गरम कर दिया गया है. When you take eutectoid steel and heat it to a temperature above A1, इसका इंटरनल स्ट्रक्चर में ऑस्टेनाइट रहता है, इसी के वास्ते वैसा वाला स्टील को बोलते हैं ऑस्टेनाइटाइज्ड eutectoid steel. So a steel which is heated to austenitic temperature, a steel which is heated to austenitic temperature is taken at above A1 and it is rapidly cooled to a temperature below A1. It is rapidly cooled to a temperature below A1. At a temperature below A1, after rapid cooling, we will try to hold it at a constant temperature, right? And then we will try to find out what is the beginning time of transformation and what is the ending time of transformation at this temperature. So I write P1, E1. So from above A1, let us say we have rapidly cooled it down to something like 700 degrees centigrade. Right? Austenitized eutectoid steel is rapidly cooled to a temperature like 700 degrees centigrade, which is below A1, and then it is held at the constant temperature for sufficiently long period of time. Right? कितना समय तक होल्ड करके रख देता है?
पता नहीं, बहुत नींद आई तो सो जाऊंगा, फिर 1 घंटा तो करूंगा अभी.
When you are holding the specimen at 700 degrees centigrade at constant temperature, you will try to observe the microstructure. With the help of a stopwatch, वहाँ पर रखते हैं stopwatch को. After rapidly cooling to 700 degrees centigrade, you put on the stopwatch. So stopwatch is starting from time t equal to 0. Right? एक तरफ से stopwatch रीडिंग चल रहा है, आप माइक्रोस्ट्रक्चर ऑब्जर्व कर रहा है. माइक्रोस्ट्रक्चर में आप आइडेंटिफाई करने के लिए ट्राई कर रहा है. कितना समय गुजर जाने के बाद वो वाला ऑस्टेनाइट टू पैरेलल ट्रांसफॉर्मेशन बिगिन होता है, दैट इज कॉल्ड एज B1. B1 is the beginning time of ऑस्टेनाइट ट्रांसफॉर्मेशन टू पैरेलल. E1 is the ending time of ऑस्टेनाइट ट्रांसफॉर्मेशन टू पैरेलल. So जैसा जैसा माइक्रोस्ट्रक्चर देख रहा है बेटा, the moment when microstructural changes commence from ऑस्टेनाइट टू पैरेलल, find out what is B1. B1 is a stopwatch reading. So B1 indicates the time at which the transformation has begun, beginning time of transformation. Is it equal to 0? No sir, it's not 0. What is the importance of 0 seconds? At time t equal to 0 seconds, आप रैपिड कूलिंग करके कांस्टेंट टेम्परेचर में मेंटेन करना शुरू कर दिया. लेकिन कांस्टेंट टेम्परेचर में मेंटेन करना जब आप शुरू कर दिया, उसी समय पे एट टाइम t इक्वल टू 0 ये वाला ट्रांसफॉर्मेशन बिगिन नहीं होता. थोड़ा समय गुजर जाएगा, मे बी 500 सेकंड्स और 5000 सेकंड्स टाइम गुजर जाएगा. बहुत ज्यादा समय गुजर जाने के बाद तब शुरू होता है ट्रांसफॉर्मेशन. देयरफॉर B1 इज नॉट इक्वल टू 0. B1 may be 5000 seconds. B1 may be 50000 seconds. B1 is beginning time for formation of parallel from austenite. B1 is the beginning time of austenite transformation to parallel. It is not 0. I. What is the importance of 0 seconds? 0 seconds में आप रैपिड कूलिंग करके होल्डिंग करना शुरू कर दिया, कांस्टेंट टेम्परेचर में होल्डिंग करना शुरू कर दिया 0 seconds में. और B1 seconds में ट्रांसफॉर्मेशन बिगिन हो गया. Now the time which is elapsed between 0 seconds to B1 seconds, that time is called as incubation time. That time is known as incubation time. When you talk about incubation time means the time which is elapsed, before beginning of the transformation, the time which is elapsed before beginning of the transformation. Right? वैसा ही जब आप देखते जाएंगे माइक्रोस्कोप में किसी न किसी समय पे ये वाला ट्रांसफॉर्मेशन कंप्लीट हो जाएगा माइक्रोस्ट्रक्चर में. So when you see in the microstructure the austenite is completely transformed into perlite, तब देखिए एक बार stopwatch की तरफ और find out what is the ending time of austenite transformation into perlite. The ending time of austenite transformation into perlite is E1. So 0 seconds is the time at which rapid cooling is done and constant temperature holding is done. B1 seconds is the time at which the transformation has begun. E1 seconds is the ending time of austenite transformation into perlite. But these are the 3 data points taken. Similarly, repeat this experiment. Repeat this experiment at various other temperatures like 600 degrees centigrade, 550 degrees centigrade, 400 degrees centigrade, 300 degrees centigrade. अलग-अलग temperatures तक rapid cooling करके data generation करोगे. Say for example, I am trying to show you here. Second sample is taken austenitized eutectoid steel, rapidly cooled to a temperature like 600 degrees centigrade. At time t equal to 0 seconds, we started holding it at a constant temperature. Then find out at that constant temperature when you hold the specimen under microscope, कौन सा समय पे austenite to perlite transformation begin होता है, that is B1. So B1, that is let us say B2, the time at which austenite to perlite transformation begins. Similarly, वैसा ही माइक्रोस्कोप में देखते जाओ, find out the time at which the transformation is complete, that is called as E2. E2 is ending time of austenite to perlite transformation at 600 degrees centigrade. B2 is beginning time of austenite transformation into perlite at 600 degrees centigrade. 0 seconds to B2 seconds is called as the incubation time at 600 degrees centigrade. Similarly, take another eutectoid steel sample is taken, rapidly cooled to a temperature like for example 550 degrees centigrade तक rapidly cooling कर दिया. Then you have started holding time at time t equal to 0 at this constant temperature. Holding time शुरू हो गया at time t equal to 0. Now holding करने के बाद थोड़ा सा समय गुजर जाने के बाद ट्रांसफॉर्मेशन शुरू होता है. So we try to find out what is the beginning time of austenite transformation into perlite at this particular temperature. We call it as B3, beginning time of austenite perlite transformation. Then वैसा ही हम देखते जाएंगे microstructure में until the transformation is complete to perlite in the microstructure. The transformation completion time is called as E3, that is ending time of austenite to perlite transformation. All right. After coming up to this particular temperature, second generation of transformations we start. The second generation of transformations are known as binitic region. This is called as binitic region. That means below 550 degrees centigrade, arsenic will not transform into perlite. Below 550 degrees centigrade, by constant temperature holding, arsenic will start transforming into bynite. Yesterday you have seen in high temperature tempering, by constant temperature holding below A1, arsenic transform into bynite. बोल के देख लिया था. Same way here. अब क्या करना है? Take a austenitized electrolyte steel and rapidly cool it to a temperature like 500 degrees centigrade, right? And hold it at a particular constant temperature. Then find out at this constant temperature what is the beginning time and what is the ending time of arsenite transformation into bynite. Repeat the experiment. Take another electrolyte steel, rapidly cool it down to 400 degrees centigrade. Again find out what is the beginning time of transformation of arsenite into bynite and what is the ending time of arsenite transformation into bynite. Repeat this. Take another austenitized electrolyte steel, rapidly cool it down to something like 300 degrees centigrade. Hold it at a constant temperature and find out what is the beginning time of arsenite transformation into bynite at 300 degrees centigrade, that is B6, and what is the ending time for arsenite to bynite transformation at 300 degrees centigrade, okay, E6. Find out here. Once you have this data with you, now let me tell you, after a particular temperature, arsenic will not transform into bynite. Well, sir, yesterday we have seen MS temperature बोल के कुछ रखता है. What is that? Below 500, below 210 degrees centigrade, below 210 degrees centigrade, arsenic will transform into martensite. Martensite formation शुरू होता है, बोलते मैं बोल रहा था MS temperature बोल. Therefore, below a particular temperature, if you repeat this entire process, say for example, austenitized electrolyte steel area, rapidly cool it down to 210 degrees centigrade. Then at that temperature, you try to find out 210. What is the importance of 210? Martensite formation starting temperature. Right? So martensite formation शुरू होता है. इसी के वास्ते ये व्हाइट लाइन से राइट साइड में जो फेज तुम्हारे को मिलने वाला है, that is martensite phase. That is called martensite phase. That means below a particular temperature, yes, below a particular temperature, arsenite will not transform into bynite. Instead, arsenite will start transforming into martensite. So जैसा जैसा आप इस constant temperature में स्पेसिफिक को रख दिया और माइक्रोस्कोप में माइक्रोस्ट्रक्चरल ऑब्जर्वेशन बनाते रहा, you try to find out what is the beginning time of arsenite transformation into martensite and what is the ending time of arsenite transformation into martensite. Beginning time of arsenite to martensite transformation is B7. Ending time of arsenite to martensite transformation is B7. Now बेटा, in all our observations अभी तक जो मैं आपके सामने दिखाया था, this is how data generation is done. Austenitized electrolyte steel is taken, rapidly cooled to a temperature below A1, held at that constant temperature, time t equal to 0 seconds. Then we keep on observing microstructure. When the microstructure change begins, that's called as beginning time. B1, B2, B3, B4, B5, B6, they are all beginning times of arsenite transformation. Next. Similarly, we keep on observing what will be the ending time of transformation. Those ending times of transformation are denoted by E1, E2, E3, E4, etc. Right? So all B points are beginning times of arsenite transformation. All E points are ending time of transformation of arsenite. Now, at different temperature ranges, arsenite transformation product will be different. Up to 550 degrees centigrade, arsenite will transform into perlite. Below 550 degrees centigrade, by constant temperature holding, arsenite will transform into bynite. Below 210 degrees centigrade, arsenite will start transforming into martensite. These are the observations. अब हम लोग क्या करेंगे? ये जो डेटा यहाँ पर जनरेशन करके रख दिया गया है, we'll try to transfer this data to construct what is known as TTT diagram. Right? Let me try to show you that. I try to represent all this data for develop drawing of TTT diagram. Right? How do we proceed, sir? TTT diagram construction करने के लिए we have to draw two diagrams, one above the other. This is the first diagram that we are trying to draw. On this diagram, right, on the left side y-axis we take austenite percentage. On the right side y-axis we take perlite percentage. And on the x-axis we try to show time. On the x-axis we try to show time. On the left side y-axis we say austenite percent goes from 100% in the beginning to 0% in the ending of transformation. Austenite percent goes from 100% in the beginning of transformation to 0% in the ending of transformation. In the beginning of transformation, perlite is 0%, and in the ending of transformation, perlite becomes 100%. Therefore, ये जो line है बेटा यहाँ पर, the line which shows austenite 100% and perlite 0%, called as beginning line of transformation. This line is known as beginning line of transformation. Similarly, ये जो line है, the line which is going 0% austenite and 100% perlite दिखाने वाला ये जो other line है, this line is known as ending line of transformation. This line is called हिंटिंग लाइन ऑफ ट्रांसफॉर्मेशन। वैसा मैं कन्वेंशन क्यों बता दे रहा हूं? एक सिंपल इंफॉर्मेशन है बेटा, जो डेटा पॉइंट्स मैं बताया था, दिखाया था तुम्हारे B1 B2 B3 B4 B5 B6 B7, they are all beginning point, beginning time of transformation. All beginning times of transformation, B1 B2 B3 etc., they will all come on the beginning line. And all E points, E1 E2 E3 etc., they are all ending times of transformation. All E points will come on this ending line by deposition. What is clear? Right. अब हम लोग क्या करेंगे? Let's say for example, let me show you the data once and then take you forward. From this data, we understand at 700 degrees centigrade, B1 is the beginning time, E1 is the ending time. So हम लोग क्या करेंगे बेटा? These are stopwatch time readings. All B points and E points are stopwatch time readings. Therefore, हमारे को B1 का टाइम वैल्यू मालूम है, E1 का टाइम वैल्यू मालूम है at 700 डिग्री सेंटीग्रेड. तो आइए हम लोग सीधा क्या करेंगे? At these operations हम लोग exactly ये वाला पॉइंट्स का आइडेंटिफिकेशन कर देंगे. Say for example, let me identify B1 here. This is B1 and this will be E1. If you join this line B1 E1, this is called the transformation curve. Now this is the transformation curve at 700 degree centigrade. At 700 degree centigrade. Now you can always ask me, sir, B1 को इतना दूर में क्यों इंडिकेट कर दिया? बेटा 0 to B1 on the x-axis जो
चलो पानी भर के आते हैं. लाइट लगाना पड़ेगा अभी, अंधेरा है. भर लिया पानी. लाइट बंद करना पड़ेगा अभी. अभी वापस ट्राइपॉड में लगा देते हैं मोबाइल को। परफेक्ट, थोड़ा बहुत परफेक्ट।
That's called the beginning time. B1, B2, B3, B4, B5, B6. They are all beginning.
हेलो भाई, मिशन IIS। कैसी शुरू है पढ़ाई? ठीक है। किस कोचिंग से पढ़ रहे हो? मेड इजी। मैं एडमिनिस्ट्रेटिव सर्विस के लिए नहीं कर रहा है, इंजीनियरिंग सर्विस के लिए कर रहा, टेक्निकल।
of arsenic transformation. Next. Similarly, we keep on observing what will be the ending time of transformation. Those ending times of transformation are denoted by E1, E2, E3, E4, etc. Right? So all deep. So ending times of arsenic transformation. All E points are ending time of transformation of arsenite. Now, at different temperature ranges, arsenite transformation products will be different. Up to 550 degrees centigrade, arsenite will transform into perlite. Below 550 degrees centigrade, by constant temperature holding, arsenite will transform into bylite. Below 210 degrees centigrade, arsenite will start transforming into martensite. These are the observations. अब हम लोग क्या करेंगे? ये जो डेटा यहाँ, that is called martensite phase. That martensite को ले लिया, rapidly cooled it down. You try to find out 210. What is the importance of 210? Martensite formation starting temperature. Now, at different temperature ranges, arsenite transformation product will be different. Up to 550 degrees centigrade, arsenite will transform into perlite. Below 550 degrees centigrade, by constant temperature holding, arsenite will transform into bylite. Below 210 degrees centigrade, arsenite will start transforming into martensite. These are the observations. Let me try to show you that. I try to represent all this data for drawing of GTD diagram. Right. How do we proceed, sir? GTD diagram construction करने के लिए we have to draw two diagrams, one above the other. This is the first diagram that we are trying to draw. This is the first diagram that we are trying to draw. On this diagram, friends, on the left side y-axis we take arsenite percentage. On the right side y-axis we take perlite percentage. And on the x-axis we try to show time. On the x-axis we try to show time. On the left side y-axis, we say arsenite percent goes from 100% in the beginning to 0% in the ending of transformation. Arsenite percent goes from 100% in the beginning of transformation to 0% in the ending of transformation. In the beginning of transformation, perlite is 0%, and in the ending of transformation, perlite becomes 100%. Therefore, ये जो line है बेटा यहाँ पर, the line which shows arsenite 100% and perlite 0%, called as beginning line of transformation. This line is known as beginning line of transformation. This line is known as beginning line of transformation. Similarly, ये जो line है, the line which is going 0% arsenic and 100% perlite दिखाने वाला ये जो आदत line है, this line is known as ending line of transformation. This line is called ending line of transformation. वैसा मैं convention क्यों बता दे रहा? एक simple information है बेटा. जो data points मैं बताया था, दिखाया था तुम्हारे B1, B2, B3, B4, B5, B6, B7. They are all beginning point, beginning time of transformation. All beginning times of transformation, B1, B2, B3, etc. They will all come on the beginning line. And all E points, E1, E2, E3, etc. They are all ending times of transformation. All E points will come on this ending line by deposition. Point is clear? Right. अब हम लोग क्या करेंगे? Let's say, for example, let me show you the data once and then take you forward. From this data, we understand at 700 degrees centigrade, B1 is the beginning time, E1 is the ending time. So हम लोग क्या करेंगे बेटा? These are stopwatch time readings. All B points and E points are stopwatch time readings. Therefore, हमारे को B1 का टाइम वैल्यू मालूम है, E1 का टाइम वैल्यू मालूम है at 700 डिग्री सेंटीग्रेड. तो आइए हम लोग सीधा क्या करेंगे? At this टेम्परेचर हम लोग exactly ये वाला पॉइंट्स का आइडेंटिफिकेशन कर देंगे. Say for example, let me identify B1 here. This is B1 and this will be E1. If you join this line B1 E1, I find out this is called the transformation curve. Now this is the transformation curve at 700 degree centigrade. At 700 degree centigrade. Now you can always ask me, sir B1 को इतना दूर में क्यों इंडिकेट कर दिया? बेटा 0 to B1 on the x-axis जो टाइम तुम्हारे मिल रहा है, it is called as incubation time at 700 degree centigrade. It is called as incubation time. तो incubation time का क्या मतलब है सर? The time which is elapsed between beginning of transformation and beginning of holding time at constant temperature. 700 degree centigrade में constant temperature में holding करना और ट्रांसफॉर्मेशन बिगिन होना, ये दोनों एस्पेक्ट्स के बीच में जितना समय गुजर गया है, दैट इज कॉल्ड एज 0 to B1, दैट इज कॉल्ड इंक्यूबेशन टाइम. हाई टेंपरेचर में इंक्यूबेशन टाइम ज्यादा रहता है. आगे बढ़ते हैं. व्हेन यू ट्राई टू टेक द आइडेंटिफिकेशन ऑफ सेकंड टाइम B2 E2 at 600 degree centigrade, B2 इधर आएगा, B2 will come here and E2 will come here. Now when you join this B2 E2, this is the transformation curve at 600 degree centigrade. 0 to B2 is the incubation time at 600 degree centigrade. Similarly, when you plot the third readings B3 and E3, line joining this B3 E3 is the transformation curve at 550 degrees centigrade. Is the transformation curve at 550 degrees centigrade. All right. Now, तुम्हारा observation मैं जानना चाहता हूँ. At 700 degrees centigrade, 0 to B1 is the incubation time. At 600 degrees centigrade, 0 to B2 is the incubation time. At 550 degrees centigrade, 0 to B3 is the incubation time. So incubation time बोले तो मतलब क्या है बेटा? नया फेज फॉर्मेशन शुरू होने से पहले, नया फेज फॉर्मेशन शुरू होने से पहले जितना समय गुजर गया है, that is called incubation time. The time which is elapsed before beginning of formation of new phase. So 700 degree centigrade में incubation time 0 to B1 है, 600 degree centigrade में 0 to B2 है, 550 degree centigrade में 0 to B3 है. So what is your observation? As the temperature is decreased from 700 to 600, 600 to 550, what happened to incubation time? Incubation time is decreased with the decrease in temperature. Correct? So in interview people will ask you, why the incubation time is decreasing? Why the incubation time is decreasing with the decrease in temperature? वो decrease में पूछता है बेटा. इसका समाधान तुम्हारे कहाँ मिलता है? ये वाला डायग्राम में. देखो. With the decrease in temperature, nucleation rate is increasing. That means per unit time, more and more number of nucleation, more and more number of locations में paralytic formation शुरू होता है. That is nucleation rate. At low temperature, since nucleation rate is more, तुम्हारे को नया phase formation के लिए इंतजार करने का समय कम होता है. At low temperature, since nucleation rate is more, your waiting time for formation of new phase will decrease. That is why, with the decrease in temperature, incubation time will decrease. That is how this diagram helps us to answer the questions which come in the next diagrams. Right. So here we are. As the temperature decreased from 700 to 600, 600 to 550, whatever, incubation time decreased from 0 B1 to 0 B2, and then from 0 B2 to 0 B3. Why incubation time decreased? Waiting time क्यों decrease हो गया? Because at low temperatures, nucleation rate increases. That is why waiting time will decrease. Hence incubation time will decrease. That is why incubation time decreases. All right, sir. अब आइए. At 500 degrees centigrade, when you go to decreasing of temperatures, at 500 degrees centigrade, B4, E4 are the data points. So let me try to show you that. Before I show those data points, let me try to take a little higher, and then is that exactly नीचे second UTT diagram exactly below this, उतना ही exactly below this And in the same width, मैं क्या कर रहा हूँ? I am trying to show you another diagram. This final diagram is called as TTT diagram. So on y-axis there is temperature. On y-axis there is temperature, and on x-axis there is time. On TTT diagram, on x-axis there will be time. So let me try to show you that. On x-axis there is time. Is this diagram that is going to be called as TTT diagram. अब कैसा शुरू करें सर इसको? एक दो fundamentals हैं. First, draw a line that is called as A1 line at 727 degrees centigrade. At 727 degrees centigrade, draw a horizontal line. And you know, friends, above A1 line, arsenic is stable. Therefore, A1 line, A1 is constant temperature line, 727 degree centigrade line. इसके ऊपर लिख लीजिए, arsenic is stable. नीचे, A1 के नीचे, according to Peptide reaction, arsenic becomes unstable and hence it transforms into perlite. Therefore, below A1 कौन रहता है? Unstable arsenic रहता है. Below A1, unstable arsenic रहता है. Right. अब क्या है? See what are the temperatures taken here? 700, 600, 550. So identify them here. Let us say this is 700, this is 600, this is 550 degrees centigrade. Draw constant temperature lines. This is the constant temperature line at 700, this is at 600, this is at 550. Okay. So now your next immediate job is to transfer the B points and E points by projection onto corresponding temperatures. देखिए बेटा, let me try to show you. By projection लेना है, yes. So B1, E1, come on, B1, E1 belong to 700 degrees centigrade. Therefore, project B1 and E1 to 700 line. Project B1 to 700 line. This is B1. Project E1 to 700 line. This is E1. Similarly, project B2, E2 to 600 line. Project B2, E2. This is B2. This is E2 here. If you come here, this is E2 to 600 line. Project B3, E3 to 550 line. Take B3 to 550 line. And project E3 to 550 line. This is E3. Sir, अब क्या करूँ मैं? Friends, all B points indicate beginning time of transformation. Since all B points are indicating same logic, beginning time को indicate कर रहा है. Join all B points by a common locus. Therefore, let me try to draw it. Join all B points by a common locus. Join B1 to B2, B2 to B3, B1 to B2, B2 to B3. Similarly, all E points indicate beginning of transformation time. Therefore, join all E points by a common locus. Join E1 to E2, E2 to E3. Done. Upwards. Now, if I come करने के बाद, next task that is done by you is, sir, you have represented from all the way up to 750 degree centigrade. All these data points are transferred by projection. अब बाकी data है हमारे पास, by that region में, mark that region. Identify them. Before E4 representation करने से, B4 will come here, and E4 will come here. On the right side आएगा, B4, E4. This is the transformation curve at 500 degree centigrade. Similarly, B5, E5 will come here. B5, E5 will come to the right side of B2 and E2. So if you join B5, E5, if you join B5, E5, that line is going to the transformation curve at 400 degree centigrade. If you now draw B6, E6, this will be